to watch. We speak and it
On
happens.
cue.
Yeah. Yes. I'm Casey Maddox. I'm have the privilege of working with the American Statistical Association as the director of data science of K-12 education outreach. And we have Donald Lalonde and Rebecca Nichols from ASA with us tonight, and Emily Thrasher from NC State. And so we want to welcome them. And then we have special guests with us from Stata, and we'll get them to introduce themselves in just a minute. I wanted to remind you that Stats and Data Net is a year-long professional learning effort organized by the Joint Committee of the American Statistical Association and the National Council of Teachers of Mathematics. It provides K-12 teachers with an opportunity to discuss and apply the data analysis, data science, and statistical concepts embodied in the National Council of Teachers of Math catalyzing change books, as well as ASA's guidelines for assessment and instruction in statistics education for pre-K-12 curriculum. And so teachers will learn to use strategies and technology tools that support students' learning and empower them to investigate questions using real-world data. And we will offer you the opportunity to download a certificate at the end of our session tonight. So we do want to say welcome. And so we have Kristen and Megan from Stata that are with us tonight. And so I know they have much to share. So we're going to go ahead and ask them to introduce themselves and take over. Thank you very much for being with us tonight.
All right. Well, I'm Megan Kane. I'll be your presenter tonight. I am the Assistant Director of Educational Services here at Stata. So, what that means is I oversee our webinars, training materials. I do a lot of workshops, videos, stuff like that. Basically, just say I just talk about statistics for a living, which has always been my dream and my passion. I am very much excited to share Stata with all of you. I think it's so important to get kids as young as possible to start thinking about data and start thinking about statistics. And so I'm just so thrilled to be here. Thank you for having me.
Yeah, really quick. I'm Kristen McDonald. I'm a statistician and I work with our documentation and Stata Press books and a little bit on the design end of new features that we're adding and reviewing those before they reach users' hands to make sure they're as Stata-like and user-friendly as possible. Today, I will be watching the chat window, so if you have questions as Megan's talking that you would like to have addressed in the chat, feel free to type those and I'll keep an eye on that and try to answer any Stata-related questions you have. Okay, Megan, I'll turn it over to you.
All right, sounds good. Let me share my screen. Okay, we'll start with I just have a few slides for you guys. Let me hide the video of myself because that is too much. All right, so welcome to Teaching Data and Statistics with Stata, Examples for the Classroom. Again, my name is Megan Kane. And what we're going to do tonight is I'm going to start with just a brief tour of Stata, especially for those of you who have never used it before, just to give you a feel for what it is and what you can do with it. And then I'm going to work through these examples. So I have an example on music choice and then an example from an online data repository, Census at School. And so I have quite a few things to show you within those two examples. And then I'll tell you how to actually get Stata for you in your classroom. Stata does offer free licenses for K through 12 teachers and classrooms. And so I want to make sure you know how to take advantage of that if that is something that you want to do with your classes in the future. And then I'll end today by just talking about a few of our learning resources and where you can get further support for Stata if you need it. So let's start with a tour. So this is what the Stata interface looks like. So let me go ahead and switch into Stata. So what you see here is we have these 5 different windows: history, results, command, variables, and properties. Okay, so results is where all the exciting stuff happens. Command is where you can put in a command, and then you'll see that command and the results in the window above. So this will be a little bit more exciting to demonstrate for you if we have a data set loaded. So I'm going to go ahead and go to File. And you can see you can use File to open a data set, to change the working directory, and then we also have example data sets. So I'm going to click on example data sets, and I'm going to click example data sets installed with Stata. So that means is just they're on your computer already. If you have Stata installed, you have access to all of these data sets. And so I very much encourage you to take advantage of that and use these for any examples you might need them for. So our kind of classic data set we use a lot at Stata is this auto data set. So I'm going to go ahead and click the Use button, and then I'm going to X out of this. And you see that issued the sysuse command and then auto.dta. And it's telling me that this is a data set on 1978 automobile data. And now that we have a data set loaded, you can see the right panel is filled in. So at the top right, we have our variables window. So you can see the name of each of our variables in this data set and then a short, what we call a label or a short description of it. And then below that, we have our variable properties. So if you click on a particular variable, you can see properties for that variable here, and then properties for the data set below. So we can see this data set has 12 variables and 74 observations. If you want to make any changes to these properties, you just have to unlock this little lock here. Now, to take a look at your data set, we have two data editors. So those are these buttons that look like spreadsheets at the top here. So there's one with a pencil on it that is edit mode. That means you want to make changes to your data set. And then we also have browse mode, where you just want to look at your data set. And so I'm going to click browse mode just so you can take a quick peek at this data set. So you can see it's all different types of cars. These are string variables. That's why they're in red. And then we have some information about each of these cars in 1978. So their price, their miles per gallon. This is a repair record variable, how big the car is. And then we have this variable called foreign, which is telling us whether that car is foreign or domestic. And you can see that these words are in blue instead of red. So the red again is a string, whereas the blue is what we call a factor variable. So you can see that if I click on domestic, it's actually stored as a 0. It's just showing up as domestic because that's a label we've added to that. Okay, so that's the label that will show up in your tables and graphs and stuff like that. And if we scroll down to foreign, you can see that that's actually coded as a 1. Okay, so we'll do an example later today where we need to turn a string variable into a factor variable. Okay, so let me X out of that. So these are variables, properties, again, results is where all the action happens. We went over file. I'm going to go ahead and change my working directory while we're here. And I'm going to change it to where I put all the materials for the session today. So I'm going to go to Documents, and then I put them in a folder called AMSTAT. And so now once I'm in this folder, everything I do will happen here. So any data set I open, it's first going to look for it in this folder. Anytime I save a file, it'll save it in this folder unless I tell it otherwise. Okay. So from here, you can go to Edit. Really, the only thing you probably want to change here is preferences. You can change the look of Stata here. Data, you can describe data, change data, create new variables here. So if I go to describe data in memory or in a file, it'll bring up a dialog box. So I'm just going to say OK. And you see that that dialog box issued the describe command, and then we see the output from that command below. So that's one way that you can do commands in Stata. The other way is you can just type them in the command window. So if I type summarize, and actually, sorry, let me make that font a little bit bigger for you. So if I type summarize in the command window, that will show up in the results window too. So those are two ways you can interact with Stata, is again using this menu system or just typing commands into this command window. The other way in that you would interact with Stata is through do files. So this would probably be for more upper level students. So I have a do file here, for example, with all the examples I'm going to do tonight, uh, if we have time. And so you can see it's just a collection of commands. And then I can put comments in here. I could put bookmarks in here so you can see I have different examples, and then I have my different levels here. And please be gracious with me about these levels, A, B, and C. I did my best to learn about what students at different ages learn. So I roughly cut it into A, B, and C, but please be nice to me if I did not get that cut exactly right. So that, again, this is the other way that you can interact with data. So for people who are brand new to Stata, I would say just use the menu system. Just use these dialog boxes. That's the easiest way to do it. And then as you use these dialog boxes, you'll see these commands pop up in your results window. And so you'll just naturally learn these commands as you use the menu system. And then also, now that we've used a few commands, you can see in our history window, we can see those commands here as well. Okay, so this history window is a good thing to keep track of what we're doing. So we did file, that's to open data sets. You can import data sets from any of these sources. I'll show you a couple examples of that today. You can also export data or results to several sources as well. A data, again, to create change describe data. Graphics, we'll spend a lot of time here tonight. So two-way graphs, so it says scatter, line, etc. This is any graph that has a numeric x and y axis. And so there are quite a few graphs you can get from there. Tonight we'll be doing a lot of bar charts, histograms, box plots. We'll also do some scatter plots, and then you can see below we have more specialized graphs for time series analysis, panel data, survival, etc. Statistics, we're going to be spending the majority of our time tonight in this very first tab, summaries, tables, and tests. So we have several summary statistics that we can calculate. We have different kinds of tables that we can create. And then we also have classical tests of hypotheses here. So t-tests, z-tests, etc. If we have time at the end, I'll show you a linear regression example. You can see you can also get to ANOVA from this menu. I don't know if any of you go as far as logistic regression, but we have that here too. But the point here is that Stata has a lot, right? So I'm going to show you some very basic stuff today. But the hope is that if students get comfortable with data earlier on, then once they get to college, even grad school, and they start using these more complex analyses like time series, multi-level, survival analysis, SEM, etc., if they're already familiar with data, they'll be a step ahead of everyone else who's just learning it for the first time, right? And so we say that state is easy to learn, easy to grow with. So we hope that it's intuitive for you to do this basic stuff, and then also intuitive to then extend that knowledge to other analyses. And I think that's one of the best things about Stata is that all of the commands have very similar syntax to each other. So once you know how to do one thing in Stata, it's really easy to learn how to do other things in Stata because our language is consistent across analyses. Okay, so that is about all I have for you as far as our tour goes. So let's go ahead and start an example. Do, do, do. Sorry, trying to find my slides. Oh, here. So, to get these examples, I looked at this guidelines for assessment and instruction in statistical education. So I can go ahead and open this. So I looked at this report and there are a bunch of examples in here. I don't know how often any of you actually use these examples, but I at least use these to inspire the examples I'll be going over tonight. I also used the data sets that are here. So data sets and supplementary materials. So you'll see some of those data sets from here as well. So that's where I got these examples. So I'm going to start with this choosing music for the school dance example. So this is in the level A section of that guide that I just showed you. And in that guide, it shows you this kind of raw data that you've collected. So I'm sure if you're doing this in your classroom, you would actually have students collect data. And so you can see it's just the name of every kid in this class. And then it's what type of music they want at the school dance. Okay. And so they only got three choices: country music, rap music, or rock music. Oop, oh, sorry. Windows are going crazy. And so this is a very simple data set that you can start with. So I'm going to show you how to put this data into Stata. And so we're going to start with the clear command. So you can see clear cleared out the data we have. So now when I open a data editor, and I'm going to open the one with the pencil, the edit mode, you can see there's nothing here because I cleared out the data. So I'm going to start by just typing in that data we just saw. So I actually put this in an Excel sheet, and you could just import from Excel, but I want to demonstrate how you could actually just type data directly into Stata. So you can just start typing. So Aaron, Aiden, Alex, Angelica, Anna, Ariella, etc. So I could keep typing all these names in. To save time, I will copy and paste the rest of them. So I ended with Ariella. I'm going to go from Eliana, copy, and then paste. And then it's going to ask me if the first row of what I'm pasting is a variable name. It's not, it's just data. So I'm going to say data. And then you can see it created this variable that's just called var1 with our names. So I probably want to change the name of that variable. So I can click this, and then in this properties window, you can see the name of this variable is var1. I'm going to change that to name. And then I can give it a label. So I'm going to give it the label child's name or student's name. And then I can do the same thing with the type of music they like. So I can just type in rap, rock, country, etc. I'm going to just copy and paste this to save time again. So we're going to copy and paste. And this time that does include the variable name. So I'm going to click variable names. And you can see that created a variable named music with the label music capital. So I'm just going to change the label to music choice. Okay. So the type of music they want to see at the school dance. So then I can X out of this, I can X out of that. And so I have my data set loaded now. And so I'm going to start with a really simple command just to see what's in this. So I'm going to go to statistics, summaries, tables, and tests, and frequency tables. And then I just have one variable in here I want to look at. So I want a one-way table. So this opens up the dialog box for the tabulate command. And so you put in your categorical variable. So I want to look at music. And then I say, okay. And you can see that issues the command tabulate music. Okay. And so this tells me that in this class of 24 students, 8 of them want country music, 12 want rap, and 4 want rock. And then we can see the percentages here as well. So this is also a really good first step to do just for data integrity. So I know that when I was playing around with this and actually typing in the country, rap, rock, etc. Every time I did it, I had at least one typo or one misspelling, and so you would see a fourth category here if that is the case. And so if that does happen, you can just go back to the data editor in the edit mode and just retype whichever one was typed incorrectly. So just so you know, if you have them type it in, that will probably happen. And then here I'm just going to look at my data a little bit. So I can use the list command, and this will just list my whole data set like this. And so this is nice if you want to look at a particular category of your data. So maybe I want to say list if music equals country. Okay. So this says I want to list my data, but only if this music variable is country. And so what that will do is it'll give me a list of all of the names of students who like country. Okay. And you can make this even more sophisticated. You can say by sort music. So that means by music type, I want to list the names. So then you'll get this long output. We say music equals country. Here are the names of students who like country. Here are the names of students who like rap. Here are the names of students who like rock. And so I think just getting comfortable with these if statements and comfortable with these by statements is really useful just throughout your time using data. And just a note here that can be a little tricky is when you use this if you want to say if music is something, you have to do this double equal sign. Okay, so this double equal sign is to check if those two things are equal, whereas a one equal sign is to actually give a value to something. So we'll see an example of both. But if you're using if, you need that double equal sign. So from here, we might want to look at a bar chart of these music choices. So we can go to graphics, bar chart, and we can make a few different types of bar charts here. I'm going to click graph of frequencies within categories. And then for my categories tab, I'm going to say music. Okay. And then if I click submit instead of OK, it will still submit this command, but it will also keep this dialog box open so that I can keep making options or formatting changes. So I'm going to say submit. And it's usually not this slow. It's the first graph you make is always a little slow. And so this is the bar chart that created. Sorry, I'm trying to just make this a little bit bigger. There we go. And so you can see it has frequency on the y-axis by default, and then it has country music, rap, and rock. And so we probably want to add some titles and labels here. So I could go to y-axis to add a label for that. So I'm going to say number of students instead of frequency. Click submit. And so then you can see that right here. I'm also going to add an overall title. So I'm going to call this music choice for dance. Click submit, and then you can see that title above. If you want this bar chart to be horizontal instead of vertical, you can go back to the main tab and click horizontal and click submit. So we can see we still have our labels and titles here, but now we just have a horizontal orientation. Okay, so that's about all you can do with this particular data set. So now we're going to move on to the next data set. So this is the data set that's used in the B and C levels of this example in that guide, where they had students ask these 4 questions. So check yes or no if you like any of these following types of music. What is your favorite type of music? What is your second favorite type of music? And would you prefer to have a live band or a DJ at the school dance? Okay. So we can load this data set into Stata by going to File, Import, Excel, because all those data sets that are on that website are all in Excel format. So I click Excel and browse, and you can see it's automatically in my working directory that I changed to earlier. So these are my 3 Excel files that are in this folder. So I click Music Preference Data, and we can see a preview of that below. And we want to check this import first row as variable names so that that first row is our variable name. So we say, okay, and you're going to get this pop up. Do you want to continue and lose unsaved data? Yes, I don't care about saving that previous data set. And so you can see this issue, the import Excel command. And now if I take a look at my data with the data browser, you can see that this is all string data. We have which class the student's from, their no's and yeses on each type of music. And then we have these 2 favorite type of music variables. So there's a favorite type of music original and a favorite type of music. So the difference between these is in the original, they could put anything for that other. So we have 80s, we have upbeat. Didn't know that was a kind of music. And then in this variable, those have all just been coded as other. And so depending on what you're trying to teach, you could use either variable. I'm going to stick with this favorite type of music variable. And then the second favorite type of music is coded the same way. And then we have our choice of DJ or live band. Okay, so you can say similar idea to the previous data set, just a little bit more complicated. So from here, we can look at a tabulation table of our favorite type of music. So we could go through the menu system again, or since we already learned that command, I can just type tabulate and then which variable I want to tabulate. So I'm going to click the second favorite type of music variable. I'm going to double click it, and then you can see it shows up down here. And so we can see from here that most students like R&B, rap, and rock music. And we can make a bar chart of this just as we did before. So if I go to graphics, bar chart, so this is going to have everything that we used before. If you want to start over, you can click the reset button down here. But we're going to actually make a very similar bar chart to what we just did. So I'm going to go ahead and keep it. And I'm going to go to categories. And instead of music here, I'm going to click that second favorite music variable and click submit. And so again, we see a very similar bar chart to what we saw before with the number of students who now this is their favorite type of music. So if we wanted to change this title, we could. So instead of music choice for dance, we can say favorite type of music and submit. And then at this higher level, you can look at these bar charts by other variables, right? So all of our graphing dialog boxes have this by tab. And so if I click draw subgroups for unique values of variables, I can say, oh, I want to look at this bar chart by some other categorical variable. So I'm going to scroll down to the bottom and look at it by choice, live band, or DJ. Click submit. And then you can see I get 2 bar charts now, one for students who want a DJ and one for students who want a live band. We can also look at multiple categories in our bar chart itself. So I'm going to go ahead and unclick this again and then go to categories. And I'm going to add another group. So I'm going to click group 2 and put second favorite type of music and click submit. And you'll see this looks very busy, very difficult to read. So we want to make some adjustments here. And so once you have more than one categorical group here, you have a lot of options of different ways you can handle that. And these options can get a little bit confusing, I would say. So I think it's really best just to play with this, and especially I think it'd be fun just to turn students free and have them try to create any kind of graph they can think of, and then think about, oh, does that even make sense to look at it that way, or can I read it that way? And so when you have more than 2 groups here, is when you wanna start looking at these kind of options. And so these options talk about why variables and category grouping variables. So why variables here refers to that main tab. So that's not applicable to us. We don't have any why variables. But if, for example, you're making a bar chart of means of a variable across categories, then you would have a why variable, right? But we just have categorical variables. And so what we're going to do is we're going to click this option, treat first category grouping as Y variable. And what that's going to do is it's going to color code by that variable. And so what is it color coding by? The first category. So if you go back, what it's doing is it's color coding by favorite type of music. And then that means that this y-axis here is now second favorite type of music. So I actually probably want the opposite. I want favorite type of music here and then color coded by second favorite. So I'm just going to switch these. So the first one, I'm going to put second favorite and then favorite, submit again. So now these are all my favorite types of music, and then this are my second favorite type of music. And so to make that more clear, I can go to legend and say organization and appearance. And then for title, I'm going to put second favorite type of music. Click submit. And now we can see that here. I think that looks a bit large. So I'm going to go to properties and change the size to, let's say, medium. Say submit. Okay, I'm happy with that. So I'm going to accept and accept. And then the last thing I'm going to do here is instead of having these different bars for each second favorite type of music, I just want to stack them on top of each other. So I'm going to go to options and click stack bars on Y variables. Click submit. And now I am happy with this graph. So this shows me the favorite types of music. So you can see that again, R&B, rap, and rock are the 3 most favorite types of music. And then within each of these bars, you can see the division by second favorite type of music. So for people who like R&B, their most likely second favorite type of music is rap, followed by pop, and then country. And then for people whose favorite is rap, you can see they pretty equally like pop and R&B. Where for people whose favorite type is rock, their second favorite is usually pop or maybe other. And then we can go back to our by tab and look at this by live band or DJ as well. So I'm going to go ahead and click OK this time because I'm going to be done with this graph. And so now you can see that we have these bar charts of favorite music by second favorite type of music, and then further divided by DJ and live band. So these bar charts get pretty complicated as you add more variables to them, but I think they're really fun to play with, and really, I think they help understand data and how data is connected to each other. Now, one thing I haven't showed you yet is our graph editor. I think will be especially fun for students. So if once you make a graph, you can click this button that looks like a bar chart with a pencil on it. And this is how you can make even further edits to your graph. So maybe I don't want this note down here. I can just click that and right click and say hide. And then if I click my whole graph, you can see I can add a title here, favorite type of music. And then we can see that up here. Maybe I don't like this yellow color. I think that it's really hard to see. So I can click yellow and then I can change it to really any color I want. Let's go with navy. And then you can see it shows up as navy. Right. So there are a bunch of different adjustments you can make here. I think it's also fun to play with the x axis. So if I click this and click more up here, you can say, oh, I want more ticks than that. Maybe I want 10 ticks. Okay. And now you can now you can see these 10 ticks are on top of each other because this is a small space. But you can see how that has changed here. Right. So that is another good thing to play with. I'm going to say X out of here. And I mean, data visualization is so important. I mean, there are a bunch of books written about it. So I think getting an eye for that early on would be very useful. And then our last thing we're going to do with this data set, and this is more for an upper level student, is we're going to go back to our tabulate command. So let's say we're looking at wrap, right? So this is just no or yes. And we see that of the 54 students we asked, 41 said they like wrap and 13 said they do not like wrap. Okay. And so a question we might want to ask here is, do most students like wrap? In other words, do more than half of the students like wrap? And so we can see, well, yeah, 75% is more than 50%. But if we want to test that, we can go to statistics, summaries, tables, and tests, classical tests of hypotheses. And then we have these two proportion test options. So proportion test calculator and proportion test. So I think these are both useful for teaching. I would probably start with a calculator because I think it's easier to learn what a test is doing if you actually know what pieces of data it needs to calculate the test. So here we're looking at one sample. Our sample size is 54. Our hypothesized proportion is 0.5, meaning we want to test if it's greater than 0.5. And then here for sample proportion, we can either put 0.7593, or I like using this option, use integer counts instead of proportions. And then I can just put 41 there. Say 41 out of my 54 people said they like rap music. And then I say, okay. And you see this issues the PR test I command. And it says, okay, this is testing one sample where this proportion is 0.7592, right? Just what we got above. It gives us a standard error for that. And then it gives us these are three p-values below. So we have testing whether our observed proportion is less than 50%, is not equal to 50%, and then is greater than 50%. And so our research question corresponded to this greater than, right? We were interested in whether our proportion was greater than 50%. And so it's telling you that the probability that z is greater than z, little z, this is what we got from our proportion, is 0.0001. So this is our p-value, right? And so this is telling us what the probability is of having 41 people say yes to this question if in reality only half of the students like rap. Okay. So if only half the students like rap, what's our probability of getting 41 or more extreme number of students say that they like rap? So to further understand this p-value, you can do a little simulation. And so I'm going to type clear again. So that clears out our data. And then I'm going to set obs. So this is to set the number of observations. I'm going to set it to 10,000. And the reason I'm setting it to 10,000 is because our p-value is 0.0001. So this means if I have 10,000 samples, only one of those will be significant. Only one of those will have at least 41 people say yes if the population proportion is 0.5, right? So if I have my set observations of 10,000, I should only get one where I have 41 or more. So the way you can do this is we need to generate a variable. So I'm going to go to data, create or change data, and create new variable. So I'm going to call this new variable coin because I think that's a really easy way to learn proportions, is to say, okay, I have this fair coin. It lands on heads and tails 50% of the time. So let's just simulate flipping a coin 10,000 times and see what happens. And so what we're going to do is specify a value or an expression. So I click create, and I'm going to go to functions, and then random number. So these are all of our random number generators. So again, this is definitely far more upper level student who can do simulations, but I do think using these functions is really helpful to learn what a test is actually doing behind the scenes and what that p-value actually means. And so I'm going to go to our binomial, right? Because a coin flip, that's a binomial distribution. So I'm going to double click that and it'll appear up here. And then I have to give it two arguments. So it says where n is the number of trials and p is the success probability. So n here would be 54, right? Because I have 54 students. So I want to see if I have 54 students who are flipping coins, how often are they going to get heads? And so I'm going to set my probability to 0.5 to align with our null hypothesis, right? So I say, okay, okay. So that generated this new variable called coin. And so if I look at it, this is saying, okay, I flipped a coin 54 times and 25 were heads. And then I did that again and 28 were heads. And then I did that again and 26 were heads, et cetera, et cetera, et cetera. And so you can look at this distribution, but what we want to do here is answer our question, okay, well, how many of those were 41 or more? And so we can say count. So I'm going to count the observations if my variable coin is greater than or equal to 41. And lo and behold, we get 1, meaning 1 out of 10,000 of these samples is greater than or equal to 41. So that's exactly what our p-value was telling us, right? So if we put this 1 divided by 10,000, that's our p-value, okay? So if I were to flip a coin that has a 50% probability of landing on heads 54 times, record that number, flip it 54 more times, record that number, flip it 54 more times, record that number. If I do that 10,000 times, only one of those is going to have 41 or more heads. And so that is pretty substantial evidence that our 75% we got, so our 41 students, is not, that means that we do not have an equal proportion of people here who like rap music and who do not like rap music, right? We have evidence here that this proportion, this percent of people who like rap music is greater than 50%. Okay. And so then to end this, I'm going to load my data set again. So I could import from that Excel spreadsheet again. but I also created this Stata data set for me. So I'm going to say Muse music choice and then clear to clear out the previous data. So we're back to our original data set here. And I am going to now do that proportion test using the data itself. So if I go to summaries, tables, and tests, classical tests of hypotheses, proportion test, you can see we have all these options. So again, oh, I need to create that variable. Sorry, one second. So what should have happened, sorry, when I did this is that when you do this, that no variable pops up. And that's because all of the variables in here are string variables. And so you can't do any statistics with string variables. So you can look at tabulations, you can look at bar charts, stuff like that. But if you want to do statistical test, that needs to be on numbers rather than on strings. And so before we can perform that test, we need to convert this wrap variable from a string to a number. Okay. And so we need to do that in a couple of steps. So first, I'm going to create a value label. So it's basically going to say 0 is no, 1 is yes. So there are a few ways to get to that. I'm going to go to data, um, data utilities, label utilities, and manage value labels. And you see, I already created this yes, no. I'm going to drop that just so you can see me create it again. So if I create a label, let's say I call it yes, no, I can say 0 means no, and 1 means yes. Okay. And then again, you can see that 0 is no, 1 means yes. So that issued the label define option. So we're just creating this value label. And then what I can do when I look at my data set again, I'm going to go to edit mode because I'm going to make some changes. Do you want to change to edit mode? Yes. I am going to go to data, create or change data, other variable transformation commands, and then encode value labels from string variable. So what that means is I'm going to take a string variable, but I'm going to encode it as numbers. So I click that and I say from string variable wrap to numeric variable, I'm just going to call lowercase wrap. And then you can just have it create its own value label, but I like to create my value label and then that way I can use it across different variables. So I could use the same value label, yes, no, I created really for all of these music variables if I wanted to. And when you do that, I highly recommend you click the do not extend. So what that means is if it comes across a string here that's not no or yes, I'm going to get an error. And so I usually want that error, right? To tell me that I missed a value in my label. So I say, okay. And then we can see here we created this new variable that still knows and yeses, but now it's in blue. And if you click on this, you can see it's actually encoded as a number. So now we can use that to do a statistical test. And so we can go to statistics, summaries, tables, and tests, classical tests of hypotheses, and then proportion test. And again, I'm going to do a one sample proportion test on this new wrap variable where my hypothesized proportion is 0.5. I say okay. And once again, it tells us, oh, we looked at that variable and it has 75% are ones. And so it gave us the C test, and then it gave us the same exact p-values that we got before. Okay. So again, you can either use that PR test I command to just put in the relevant information, or you can use PR test to actually use a variable in your data set. Now, last thing I'm going to do with this data set is look at the association between rap and rock music. So to do this, I'm going to go to statistics. Again, summaries tables and tests, frequency tables. So previously we clicked one way here, but now we're going to look at a two-way table. We're going to look at two variables at a time. So I'm going to look at row, which is I'm going to put rap there, and then column, I'm going to put rock. Now I'm going to click submit, and we get this contingency table, right? So it says of the 13 people who do not like rap, 10 of them like rock. And then of the 41 people who like rap, actually 24 of those people do not like rock. So it seems like there's kind of a negative association here. Right? So we have 3 people who don't like either, 17 people who like both, and then we have 34 people who disagree on rap or rock. So from here, I think a good first step with this type of data is to look at these within column relative frequencies, within row relative frequencies, and expected frequencies. Okay, so you can click submit, and you see this key above. So first it's the observed frequency, and then it's the expected frequency. So I'm sure those of you who teach this is a core concept for contingency tables. It's this expected frequency in cell counts. And then we also added row percentages and column percentages. So what that means is if I look across these two, they add up to 100%, right? So if I'm looking at people who don't like rap, 23% also don't like rock, whereas 76% like rock. And then the next number, the last number in the box here is column percentages. So there you look up and down. So you see of the people who don't like rock, 11% also don't like rap, but 88% do like rap. Right? So I think this is a really good place to start with understanding these contingency tables. And then when you're ready, you can add some tests. Right? So here's a test statistic for Pearson chi-squared, for example. And so all that does is just adds this chi-squared test of association below. So what is that? If you ever need the formulas for these, you can always click this little help icon here. And this will give you the help file for that command. So we've been using the dialog boxes mostly, but if you are using the commands, these help files are really useful. They basically tell you how to use the command. But we're going to jump to the PDF documentation. And you can see this is pretty small. Let's make it a little bigger. Oh, I clicked too fast. Too fast, too furious. Okay. Mm. And then if this ever lets me click again, I was going to show you this documentation. There we go. Okay. So our PDF documentation, we have over 19,000 pages of documentation. It's excessive. So anything you want to learn about a command, we have the documentation for it. And so the way our documentation works is it starts with some quick start examples. This is how you use the command. We have some full examples here, and I'll show you more of those later. But what I want to show you now is the methods and formulas. So we have these for all of our estimation commands. And so if you scroll down, first it defines, okay, a marginal column, marginal row, and then you can see the Pearson chi-squared test looks like this. And this is just observed minus expected, squared over expected, and then across all the cells. Right? And so that gives you your chi-squared. So that is where that number came from. This 4.966 is following that formula. And so again, if you wanted to do a little simulation study, you could simulate a chi-square distribution. So I could say clear, set obs, I'll just do 1,000 this time. And then I'm going to data, create or change data, create new variable. And let's just reset this. So I'm going to call this new variable chi-squared, generate functions, random number generator. And again, I can just scroll down and here's our chi2. This is our random number generator for chi-squared. So in order to generate a chi-squared variable, you just need the degrees of freedom. Well, we can see here the degrees of freedom of this chi-squared is 1. Where did I get that? It's the number of rows minus 1 times the number of columns minus 1. So ours is just 1 times 1 is 1. So I'm going to generate a chi-squared with 1 degree of freedom. Say okay, okay. And then I can just count if this chi-squared I just created is greater than or equal to this chi-squared we got from our table. And we got 25, which is very close to the 26 we would have expected, right? So that's what this p-value is telling us, that if we were to just generate a chi-squared with 1 degree of freedom, if we generate that 1,000 times, 26 of them should be greater than or equal to 4.966. So we got 25 because of random variation, right? So that's exactly what we want here. And then I think it could be helpful to look at this distribution. If I go to graphics, histogram, I can look at this chi-squared. You can see what a chi-squared distribution looks like. It could be nice to add a kernel density to that. So you get our classic chi-squared there. And then I'm going to go ahead and go to x-axis and add a reference line. So I'm going to say add line to graph as specified x-axis value. And I'm going to put that same chi-squared value we got from our table again. I'm going to say accept, submit. So you can see that this is what the distribution of this chi-squared would look like under the null hypothesis. And then this is the value we got in our data set. So again, you can see it's pretty extreme given the rest of the samples here. Right. Okay, so let's move on to our census example. Now there is an Excel data set included in that guidelines data sets here, but I'm going to go ahead and show you how to get it from the internet. Okay, so again, this is from the Census at School. So you can just download random samples of student responses to an online survey. I think this is really cool. If I click this, you can see it opens the Census at School page. And I'm going to go to cleaned USA data. And then I have to agree. So the reason I don't have this in your in the do file I gave out is because I'm not allowed to share the exact URL that they're going to give me for this data set. So that's probably why they have the Excel data sheet in that folder. So I say I agree that I'm not going to distribute this. And then you can select any of these you want. So if I only want to look at particular ages, genders, states, maybe I just want to look at the state where I live, for example. I could look at specific variables. I'm going to leave everything at the default and say I just want 100 people in my sample. So I just want to generate a random sample of 100 students. Okay. And so then it gives me these options. So I'm going to right click on download sample and copy link. Okay. So I don't even have to download it. I can just get the link to it. And you can, this is true for any data set on the World Wide Web. And then I'm going to go to File, Import, Delimited, because it's downloaded as a CSV file. And then I just put that address here and click OK. And again, it's going to ask me if I want to replace that data in memory. I say yes. And so it imported that data from the internet. So I can go ahead and take a look at it. You can see it has data year, class grade, state, gender, age. So the variable I want to look at in this example is height because we haven't at all looked at a continuous variable yet. So let's go ahead and look at height. So we could first take a look at this through a histogram or a dot plot. I saw that there are a lot of dot plots in that guide. We do have a dot plot. I don't love it. So if you go to distributional graphs, you can say distribution dot plot. And I can say I want to plot height, for example. Click submit. And so it'll give you a dot plot that looks like this, where it has the variable on the y-axis, and then the x-axis is the frequency. So what you might prefer is I found this community, actually Kristen found this community contributed command called strip plot. And so what that means is we didn't add this command, but a user added it, and so you can download it. So if I say help strip plot, you can see that that comes up from here. So you can see this is a command to make dot plots, and click here to install. So now it's installed on my machine. If I go back, I can look at the help file. So one of the bummers of these community contributed commands is they're not in the dialog system then. So you have to use the command. And so it looks like I say strip plot and then my variable. And then I have all these different options. So I'm going to use the stack option. So I can say strip plot height stack. And so I think this could be a little bit easier to understand where we now have height on the x-axis and then frequency on the y-axis. And again, I can open the data editor here and click on one of these dots and then say I want those dots to be large. And then I think this can be even easier to look at, right? So again, that's using the strip plot command. And then for older kids, they can look at histograms. So I'm going to go ahead and reset this. So we're going to look at a histogram of height. Say submit. And I think it's really useful to play around with bins here to see how histograms change when you use different binning. And then again, we can add this kernel density to see what the shape of this, and we can compare that to normal density. And so how does our distribution compare to a normal distribution? Right. And then from here, you can look at these histograms across groups. So again, I can go to this by tab and say draw subgroup for unique values. And I'm going to go to gender and say submit. And now I have a histogram for female students and a histogram for male students. So I might prefer to have these on top of each other rather than side by side. So you can go to subgraph organization. And then for rows and columns here, I'm going to say columns, just one. I just want one column of graphs. So I say submit. And now I like this a lot better. I can even make this bigger. So you can see here that this is our distribution for female heights, and this is our distribution for male heights. You can see that the male heights look larger than the female heights. Also, the female heights look like they're much more normally distributed than the male heights. Another thing you can do here to compare these is we can go back to our by. So by sort gender. I'm going to summarize height. So now when gender equals female, this is the mean height. standard deviation, min and max. And then for male students, this is the mean, height, standard deviation, min and max, etc. And so we might want to compare these. So to make a table to do this, we can go to statistics, summaries, tables, and tests, table of descriptive statistics. And then you can just put in the variables you want to compare. So I'm going to put arm span. I don't know, you can put all sorts of stuff in here. And then I'm going to describe variables by group. Again, I'm going to describe them by gender. Click submit. And then you can see what this made is a table where we have, okay, we have 54 female students and 46 male students. And then we have the mean height and then the standard deviation in parentheses for female and male students. And then for arm span, reaction time, memory time, etc. And so a step past this for, again, more advanced students is you can add this option, test across groups. If I say show, I'm going to go ahead and click OK. And you can see then this added a test comparing groups by these variables. And you see here it says note using test regress across levels of gender for these variables. But these are just t-tests, right? And so you can, again, go to statistics, summaries, tables, and tests, classical tests of hypotheses. And we can do a very similar thing we did with proportion tests with t-tests. So, right, we have a t-test calculator where we have a 2-sample t-test. So our first sample has 54 people. Our second sample has 46 people. And then our first sample, let's say we're looking at height, that would be 162.949 with a standard deviation of 10.753. And then our sample 2, our mean height is 173.604 with a standard deviation of 16.216. And I say, okay. And so that is testing the mean difference, right? So this is a t-test. It says the mean difference is 10.655. So it made a t-test for that. And again, we have our 3 p-values below. You can also do the t-test on the data itself, right? So we can say 2-sample using groups where we're looking at height by gender. They submit, and we get that same result here. Okay. Now let's see, how much time do we have? Just a little bit more. Let's spend the rest of our time looking at scatter plots and doing correlation. I think that's another cornerstone here. Oh, sorry, one more thing before I move on. I want to show you a bar chart that's great for visualizing t-tests. So I'm going to reset this. Say graph of summary statistics, mean. I would even say mean and confidence interval if you've learned about confidence intervals. You can look at height, again, by gender. Click submit. And then you can see, okay, yeah, the mean height of males is larger than females. And that is what our test is doing, is comparing these two, right? Okay, so now let's look at association. So let's start with a scatter plot. So I'm going to go to two-way graph and say create. And now you can see all these different types of plots, and then you can click individual plots here. So I'm going to just stick with the default scatter plot. And I'm going to look at arm span by height. So can I predict arm span based on a student's height, right? So I say submit. And we got our scatter plot here. And so from here, you can think about, well, what does this show? It shows that these are positively related to each other, right? So we can go to statistics, summaries, tables, and tests, summaries and descriptive statistics, correlations, and covariances. And so I can look at height and arm span, right? And say submit. And it says, oh, their correlation is 0.59. That's quite high. And so if I add more variables here, so let's add right foot length, for example, and say, okay, we can see that arm span and height are more highly correlated than right foot length and height. And we can see this if we create a scatter plot matrix. If we go to graphics, scatter plot matrix, we can look at height, arm span, and right foot length. Say, okay. And then I think this is useful to compare. Okay, well, we know that this is more highly correlated than this. Like, can you see why? Right. And this is actually really hard to do. So I know, um, people with PhDs in statistics have a hard time looking at scatter plots and knowing what the correlation is, because not only does it have to do with the association, but also has to do with the spread of dots. And so I think the earlier you can get kids thinking about that, probably the better, because it is a really difficult concept to learn later. So that is one way we can look at association. Remember, the other way is we can um, draw a line through that. So if we go back to our two-way graph, so we have our scatter plot, I say accept. Excuse me. And then I'm going to create another plot, a fit plot. And I'm going to add a linear prediction to my scatter plot. So I can look at arm span by height, say submit, and we can see I added this line through it, right? So this is our line that explains the relationship between arm span and height. Okay, so where did this line come from? Well, it's a linear regression line. So for more of these upper level students, you can start to actually estimate these regression lines. So I'm going to go to statistics, linear models, and related, do linear regression. So my dependent variable here is is arm span. And then my independent variable is height. And then so I'm going to say, okay. And even before students, I think, understand the t-statistic part and the p-value part here, I think once they understand algebra, right, they can understand what this regression line is saying. And so this is saying that the expected arm span for someone who is 0 centimeters tall is 64, and that each additional centimeter adds 0.61 for the arm span. So how does this relate to the plot we saw here? Well, it's kind of hard to say, right? Because if we look at the x-axis here, height starts at 100, whereas this intercept is telling us about height at 0. So I think that can be also a good discussion on, well, is intercept really useful? Do we care what the expected arm span is for someone who's of 0 height? Um, but I think matching it up to this graph is really useful too. So I'm going to go to graphics, two-way graph again. And with my linear prediction plot, I'm going to go to options. And I'm going to say override range of x for which predictions are to be calculated. So instead of it starting at 0, I'm going to, at 100, I'm going to start it at 0 and go to 200. Click accept and submit. And so now we can see our data is way over here, but our intercept is way down here. So this 64, that's what this corresponds to. And then the slope of this line is the 0.613. And then, you can extend this. But the great thing about regression is you can control for a bunch of other variables at the same time. And so if I go to sorry, I have way too many things open. If I go back to my linear regression, we can add other things here. So maybe I want to add age. Maybe I want to add gender, but I won't be able to do that. You can see gender doesn't pop up here because gender is a string variable. So to make that a number, we can do a similar thing we did before. So we go to data, create or change data, other variable transformation commands, encode value labels from string variable. And I'm going to reset this. And I'm going to say from string variable gender, I'm going to create a new variable, gender num, so a numeric gender. And so previously I had created my own label. This time I'm just going to let Stata create a label for me. So I say OK. And you see that's created this new variable gender, which is still female, male, but it's now encoded as a number. So going back to my linear regression box, I could now add gender, but because it's a categorical variable, I actually want to click these three dots here and say, yeah, it's a factor variable. Scroll all the way down, gender, add to var list. So this is true across commands in Stata that if you have a factor variable, so not a continuous variable, but a variable where 1 means this, 2 means this, 3 means this, you need to put an I dot in front of it when you do your estimation with it. So what that'll do behind the scenes is create dummy variables for that. And so I think it's really important to differentiate these continuous variables from these factor variables once you get to talking about modeling and how that's different. So we say, okay, and I'm going to say, okay. And so this ran our model where now we can see the association between between height and arm span while controlling for age and gender. And then I'll just show you a couple more things with this regression here. As from here, I think it could be really useful to look at predicted values versus residuals and think about how that relates to our model and whether our model fits our data well. So what you can do is after every single estimation command in Stata, you can go to statistics and scroll down to post estimation. So this is everything I can do after fitting a linear regression model. And so this post estimation selector will change depending on what estimation command you just ran. So we just ran a linear regression. And so all of these post estimation commands are relevant to a linear regression model. And so I'm going to start with predictions. So predictions, I'm going to double click it. And I'm going to create a new variable name. That's arm span P. So it's my predicted arm span. And I say submit. So you see it predicted that variable. And then I also want to create a variable with the residual. So I'm going to click the residuals this time, or I can do standardized residuals. You can see we have all sorts of options here. I'm going to say OK, and that created residuals. And then I think it's nice to look at these three variables side by side. So our original arm span variable, our predicted arm span variable, and then our residual. And so the way we can do that is we could use the list command like we've done previously. to list our data. Um, you can also type browse to open up the data editor, the data browser. Um, but the cool thing about this command is you can list variables afterward, and you can even do things like add if or in, kind of qualifiers like that. So I'm going to say browse um, arm span, and here I tap completed, is why that was fast. And then I want to look at residual. So I want to open the data editor and just look at these three variables. And so we can see that the observed arm span for this person is 160. Based on our model, the predicted arm span for them is 158, which means we have a residual of 1.39 because that's the difference between these two, right? So I think it could be a nice exercise to figure out where these values are coming from, right? So they're plugging the predictor values in with these estimated coefficients from this model. So that's where we're getting our predictions from. Another thing you'll want to do after fitting a regression model, let's bring up that post-estimation selector again. I'll show, let's see how much time we have. Probably not very much. I can show you two more things. Okay, post-estimation. Diagnostics are really important in statistics. Learning about the assumptions of each model and how we can evaluate the assumptions of each model. And so we try to make that easy to do. So if you go to diagnostic and analytic plots, so the most common way you would do a diagnostic plot with a linear regression model is look at the residual versus fitted. So we could just do that with the two variables we created. But we have these special commands for after a linear regression model to create these plots. So I can double click this and click OK. And you can see this is our fitted values on the x-axis and our residuals on the y-axis. So what we want to see here is the most boring plot you've ever seen in your life, right? We want this to be just around a flat line and to have equal spread across that line. And so we want to make sure this has no trend. That evaluates the linearity assumption. And we want to make sure it has equal spread. That evaluates the homoscedasticity assumption, right? So again, upper level kids definitely need to learn these assumptions and how to evaluate them. And then one last thing I want to show you here, just because it's my favorite thing in Stata, is margins. So if you look at these marginal effects commands, what these are doing is they're looking at predictions based on different, what's the word I'm looking for? On different configurations of your predictors, right? Which is a common question we have after fitting a model, and it really helps with interpreting the model. So I'm going to go ahead and just type the command here. So I'm going to say margins, and I'm just going to start with my factor variable, gender num. And so what this is saying is based on our model, the average predicted arm span for females is 162, and the average predicted arm span for males is 174. So it's like, great, these coefficients are useful. But what I really want to interpret my model is usually something more like this, right? And so I can add variables to this. So let's say I want to look at age from, I don't even know the age range of this data set. Maybe I should find that out first. So let's say summarize age. So it goes from 11 to 19. So I do margins, gender, and I'm adding, at age equals, let's say 12 to 18. And so what that's going to do is you see this at age equals 12, at age equals 13. And so it's going to give you, based on your model again, the predicted arm span for a female 12-year-old, for a male 12-year-old, for a female 13-year-old, for a male 13-year-old, et cetera, et cetera. And then after any of these margins commands, you can type margins plot, and that will plot that table for you. So now we can see as age increases, we have expected arm span increases, and that males have higher expected arm spans than females. And then once you add interactions to your plot, to your model, this plot becomes more exciting, right? So here these lines are parallel because they are not interacted in our model. But you can see that that can get very helpful as you have more complex models. And I know I only have a couple more minutes, so I want to make sure I tell you guys how you can get a free license. So if you click this link, oops, there we go. There we go. Okay, that actually clicked. And you can also just Google Stata K-12, right? And so all you have to do is fill out this form. It's the name of your school, your students. So this syllabus URL, I'm sure many of you do not actually have a syllabus. So don't mind that. You can just say, I teach second grade math, you know. I can just put something like that here. And you can submit this form, and then you can get a free 1-year STATA license for your class. So definitely check that out. And then last but not least, I wanted to tell you how you can find more support for Stata. And so if you go to our website and then go to support, mm, you have all these different resources here for you. So the one I really wanted to point out was our tech support. So if you go to technical services, this is you can email our tech services department with any question about Stata. So you can email them before you get Stata to ask, like, can Stata do this or this? And once you have Stata, you can ask them, I'm trying to figure out how to do this in Stata, but I can't do it. And you can email them, and then you can get a response usually within a day. Okay. So I highly recommend that. And then I also recommend our Ready, Set, Go webinar. That'll just give you some general information. And then I also recommend our YouTube channel. So if you go to YouTube, and I know I'm out of time, I promise this is the last thing I'm showing you. If you go to YouTube, you can search for Stata Corp, and we have our own YouTube channel here. Oh, ah, oh my gosh. Okay, I don't know if you guys could hear that ad, but I could, and it was very loud. Um, okay, and so you can see we have a bunch of different videos here: simple linear regression, Bayesian statistics, descriptive statistics, t-tests, etc. And so these are really great learning resources as well. All right, so that is all I have for you guys tonight. I hope you learned a few things about how to use data and what will be most useful for you. I do see this one question: do students need to download data, or is there an online version? You do need to download data. We don't have an online version, at least not yet. So yes, you do need to download that for your machine. But yeah, thank you guys so much for being here. Please, if you have questions, feel free to reach out. And have a good evening, everyone.
Well, Megan, we appreciate you sharing so very much. Would you put in the chat that link again to get the free 1-year subscription so that folks could get in touch with you that way?
Sure
And
thing.
I am about to put in the chat the link to the certificate for attending tonight. And so I've just done that for you, and you can download that. Thank you. You covered so many things, and we are so delighted that you went into GAZE too, which is a publication of the American Statistical Association, the Joint Committee, and looked at levels A, B, and C, and used the data that are available there. Those are just examples. Census at School is at the ASA website. There are other lesson plans and other things for that at ASA as well. So thank you, Megan, so much. Would anybody like to open your mic and ask a question real quickly before we go for the evening? Well, let me remind you that I'm about to lose it now, that our next meeting is going to be in February, and that we will send you information about that session as well, and then we meet again in April. So we're so delighted that you've been with us tonight. And thank you, Megan, and folks at Stata for joining us and given us such a great and thorough look at how to work with data sets there. Thank you, everyone. Good night.
Thank you guys so much.